Hey guys, welcome back to bit manipulation series. So in the last video we have discussed how we can check if the given number last bit is a set bit or not. And in this video we are going to discuss one more question. In this video we will try to remove the rightmost set bit of a given number. So let's first understand the problem and then we will try to understand the trick that we are going to use to solve this problem. So the question is remove the rightmost set bit of a number. Okay, now first let's understand the problem. So let's take an example. Let's say the given number is n, which is equals to 13. So if you see, the binary representation of 13 is 1101. So in the given number, this is the rightmost set bit. Now let's take one more example. N is equals to 10. So the binary representation of 10 is 1010. And if you see here, the rightmost set bit is this one. Okay, so the demand of the problem is to remove the rightmost set bit of the given number and return the result. So if we remove the rightmost set bit from this number, we will get 1100, and if we remove the rightmost set bit from this number, we will get 1000. Okay, so I hope you understand the problem. And the decimal value for this is going to be, and the decimal representation of this number is 12 and this is 8. So let's understand the trick that we are going to use to solve this problem. So here the trick that we are going to use is an equation, or we can say is a formula, where we are going to use AND operation between the number and the number minus 1, and it is going to give us the result. Okay, but how it is working, let's understand this. Let's take the same example here, which is 13. So if you see 13, it is 1101, and let's take the another example here, which is 13 minus 1. Here we are getting 12, and binary representation of 12 is nothing but 1100. Done. Now if we try to put these two value in this equation, which is nothing but the AND operation between these two number, if we try to do an AND operation, we see that this is going to be 0, this is going to be 0, this is going to be 1, and this is going to be 1, and it is returning us a value in which the rightmost set bit is now an unset bit. Now let's understand this with one more example. Again, the value is 10, the representation of 10 is 1010. Now 10 minus 1, which is 9, the representation of 9 is the representation of 9 is 1001, and if we do an AND operation between these two number, we will get 1000. Here if you see, the rightmost set bit was this, and the value in which we are getting the rightmost set bit is now an unset bit. So this is the desired result that we want, and this is nothing but 8. So how it is working, let's understand it. See, in this equation we are performing, in this equation and n minus 1, we are performing this subtraction. But why we are performing this subtraction? So in this step, if you see, whenever we subtract 1 from the given number, actually it will make the rightmost bit 0. Let's understand this with example. Let's say we have example 12. Okay, so the 12 is 1100. Now if we try to subtract 1 from the given number, then 12 will become 11. So the binary representation of 11 is nothing but 1011. Now if you see the difference here, that in the first number the rightmost set bit is this one, but in the next number, after subtracting 1, the rightmost set bit automatically converted to an unset bit. Okay, if you want to take more example, let's say 10. Okay, so the binary representation of 10 is 1010. If you perform 9, the binary representation of 9 is nothing but 1001. Again, if you see, the rightmost set bit has become an unset bit here. So this is the observation that we are using in this formula. This is the observation that we are using in this formula. And when we do an AND operation between the given number and the number less than that, then we get our desired result, which is the unset rightmost bit, okay, or basically removing the rightmost set bit. So the code is very simple, that if this is a function, let's say integer type of function we have, and the value it's contained is n, we just have to return the value of this equation. So we will return n AND operation between n and n minus 1, and it is going to return us the desired result. Its time complexity will be O of 1, and space complexity will be also O of 1. We are not using any extra space, and it is just a constant time it is just taking constant time. So I hope you understand the problem and the solution itself. In the next video we are going to discuss few more tricks. These tricks are important because these are the base that we are going to use to solve a bigger problem. Thank you for watching. See you in the next video.